Hello students, I am Dr. Anita Sharma. Welcome in my chemistry class. Today I am going to explain you some important terms of electrochemistry, that is activity, activity coefficient and ionic strength. So without further ado, let's begin. Electrochemistry paper 202. In this lecture we will learn the meaning of terms activity, activity coefficient and ionic strength. So in 1907, Lewis showed that all the molecules in the solutions are not active. That is, activity of solution is less than its concentration. Means whatever is the concentration, all the ions will not be active. Only in case of very dilute solution can act as ideal solution. In case of very dilute solution, activity is nearly equal to its concentration. So activity is equal to concentration seen in dilute solution, but it is applicable in case of dilute solution when activity is directly proportional to concentration. Or if we remove this proportionality sign, A is equal to gamma C, where gamma is the activity coefficient. So A is activity, C is concentration, gamma is activity coefficient, and we can define gamma as the fraction of concentration active ions in total concentration. So in total concentration say a fixed amount of ions, I cannot take number of ions. So if total ions present, out of those total ions, how many ions are active is called activity coefficient. So this we have to understand what is the meaning of activity coefficient. So activity is equal to gamma C, and gamma is activity coefficient where C is the concentration of that solution. So gamma is activity coefficient, and for very dilute solution, whatever will be the concentration and activity of that solution will be is equal to 1. So this gamma activity coefficient will be 1. Because activity is equal to concentration in case of very dilute solution which can act as ideal solution. Consider a reaction of salt Ba. So Ba will dissociate and will form B positive and A negative. So equilibrium constant in terms of activity, how we will write? It is the product of concentration of these products. So in terms of activity, AB plus AA minus upon ABA, where K is the equilibrium constant. Since activity is equal to the product of concentration and activity coefficient, so if concentration increases, the value of activity coefficient decreases. Here you can see. So we can write gamma is equal to A upon C. So as the concentration increases, the value of activity coefficient decreases. So there are two conditions. If the value of gamma, that is activity coefficient, is 1, it means all the ions present in the solutions are active and the solution is very dilute. So in case of very dilute solution, all the ions which is present in the solution will be active and the value of gamma will be 1. These two will be equal. When the activity and concentration are same, then the value of gamma will be 1. If the value of gamma is less than 1, it means the concentration of solution is very high and all cations and anions are not active. So on the basis of value of activity coefficient, we can determine whether our solution is dilute solution or concentrated solution. So now we will try to understand how concentration affect the activity and activity coefficient. So concentration is affecting activity and activity coefficient in different manners. See here, if our solution is very concentrated, means number of cations and anions will be more, and if number of cations and anions are more, in that condition this cation will be covered by different anions, and this anion is covered by many cations, and an ionic atmosphere is formed around this cation and this anion, and due to formation of this ionic atmosphere, this cation cannot freely move. Here also in anion, case of anion also the same thing will happen. But if our solution is dilute solution, in case of dilute solution, number of cations and anions will be less. So in that condition, if one cation is there, that cation will be covered by anions, but the number of anions will be very less. So this proper shielding will not be there, and this in this ionic atmosphere maximum solvent molecules will be present. So if number of oppositely charged ions are less, in that condition this cation will be freely move, so will be able to move freely. And here also in dilute solution, the ions which can cover, which is required to cover this anion, that is cations, will be less. So in that condition this anion will be more active because it is not too much shielded by oppositely charged ion. So now here you can understand. So when we have concentrated solution, in concentrated solution oppositely charged ions will be more, and due to more ions the ionic atmosphere will be strong, and due to this ionic atmosphere which is formed by the oppositely charged ion, the activity of respective ions will be less because they will not be able to move freely. But if solution is dilute, the ionic atmosphere will not be strong. In that condition these ions can move easily. So now we can understand, I hope you understood how concentration affect the activity and activity coefficient. Properties of activity coefficient. So first property, it is the measure of the effectiveness with which the species influences an equilibrium. And second, dilute solutions, gamma is independent of the nature of electrolyte and dependent on the ionic strength. So we have to learn what is ionic strength. So ionic strength, it is the term used instead of concentration and defined mathematically as mu. So basically ionic strength and ionic atmosphere. So what is the strength of an ion to make strong, how much is the strength of ion which can make a strong ionic atmosphere. So if ionic strength increases, then ions will not be free to migrate, because if ionic strength is there, strong ionic strength will form a strong ionic atmosphere, and ions will not be free to migrate independently. And due to formation of ionic atmosphere, the value of activity coefficient also decreases. Activity coefficient is the fraction of ions which are active out of whole concentration. So on the contrary, if ionic strength decreases means ionic atmosphere is weak, then ions will be free to migrate independently, and the value of gamma also increases. So if ionic strength is more, strong ionic atmosphere, activity coefficient will be less because ions will not be able to move freely. If ionic atmosphere low, then activity coefficient will be high. As the charge on ions increases, the ionic strength also increases. So if we compare the dipositive and monopositive cations, so the ionic strength of dipositive cations will be more because it can be covered by more negative ions. So here mu is the ionic strength, and the formula is half summation Ci Zi square. So here mu is the ionic strength, C is the concentration, Z is the charge on ions. So we will try to solve few numericals based on this formula. First example I have taken. Calculate ionic strength of 0.1 molar NaCl and 0.1 molar BaCl2. So what we need to do is, for 0.1 molar NaCl, first we will have to write the dissociation of NaCl. So here NaCl dissociates and form Na plus and Cl minus. Here the concentration of solution is 0.1 molar, while Z, which is the charge on sodium is -1 and chloride minus 1 on chloride and +1 on sodium. So this is our formula. In this formula we have to put all the values. So mu NaCl, ionic strength of NaCl is equal to half Now C is the concentration, so concentration of Na and Cl will be same, so 0.1. Charge Z, Z is charge, so charge on sodium ion is 1 and square, plus concentration of chloride ion, that is also 0.1, and charge on chloride ion -1 whole square. So when we solve this, we will get 0.1. So 0.1 is the strength, ionic strength of NaCl. Now we will calculate the ionic strength of BaCl2. So in case of 0.1 molar BaCl2, first we always have to write the dissociation. So it dissociates and will get Ba di positive and Cl negative. So ionic strength is equal to half summation Ci Zi square. So here half, now 0.1 is the concentration. So this is the concentration. Now for Ba, charge on Ba 2 plus, so 2 square, plus concentration of chloride ion, that is also 0.1, and charge on chloride ion is -1, so 1 we will write. And one more thing we have to remember, when we dissociate the molecule, how many ions or atoms are formed, that also we have to write here, or we will multiply this. So here 2, that is why we are writing here 2. To 2, 1 negative charge. So here this. When we solve this, 2 to the 4, 0.4, and here 0.2. So ionic strength of barium chloride will be 0.3. So we can say here ionic strength of NaCl is 0.1 and ionic strength of BaCl2 is 0.3, while the molality of both the solutions is 0.1 molar. And this is one graph which is showing relation between ionic strength and activity coefficient. So here you can see as the value of here value of activity coefficient, and here the value of, so as the ionic strength increases, value of activity coefficient decreases. So here you can see in case of M4. So as I already told you that as the charges increases, plus 2, plus 3, plus 4, the ionic strength increases. So here they are inversely proportional to each other, because if ionic strength is more, the ionic atmosphere will be very strong and the activity coefficient decreases. So if ionic strength is 0.1, in that condition activity coefficient is very less. When ionic strength was near about 0, that time activity coefficient was maximum. These are the references. This is all about activity coefficient and ionic strength. Thank you.